Hi, my name is Nataliia. I'm a network engineer with a team that works on ESDN products. I'm going to be continuing with the subject that Trevor started, which is IoT devices in Faucet. And I'll say how we do it from networking perspective. So Trevor started describing why it's so different, why it's so difficult to implement any solutions for IoT devices. And networks. So when we started working with devices, we discovered that their behavior on the network is very, very different. So, for example, if you connect them, like some of them talk only via multicast to broadcast. It's actually not just discovery mechanism. It's also how they communicate, and on top of that, they for example, sometimes they're not act on the network as we would expect them to. So when I started working on this project, I discovered that that the industry is growing very, very fast. So I expected the networks would be a lot more advanced. And Gartner forecasted for 2020 20% growth for the enterprise networks for enterprise IoT devices compared to 2019. However, most of the vendors, they more focused on actual feature implementation rather than network and backend. So if you talk to the vendors, features, even the new one or even legacy one, they all describe how device work from the user side. However, very often network implementation of TCP/IP stack is actually outsourced to third parties, and some of themselves, they don't even tell you a lot of details how it works. So when we faced certain challenges, for example, like chain communication, they couldn't even give us very specific, very little specifications of how to build a network. When we tried to do it on the traditional networks, what all they did is they required layer 2 flat network, which is not exactly the best. As a network engineer, it's not exactly something that I would prefer to build, especially if it's some large scale. And considering that these days we have buildings that are more going towards smart buildings, it's hundreds and then thousands of devices, layer 2 flat network are not going to scale. And there are some already known problems when we start working. There were already some known problems in that space. That, as Trevor described, there are some legacy protocols like BACnet. There are some devices that hasn't been updated in like 15 years or 10 years, and it's very static infrastructure. So we knew about these challenges, but also when we started investigating it, we discovered a lot more. So as I mentioned before, chain communication. For example, chain communication is when set of devices talk to each other via layer 2 broadcast packets, and they don't respond to the device that's requested. They actually respond to device next in the chain. So if communication breaks somewhere in between, the entire chain stops functioning. However, on the networking side, the devices can pin each other, and yet they don't function, which is kind of hard to troubleshoot from on a traditional network because we don't have visibility. All we see is layer 2 broadcast packets. It's always known that that building management system and Internet of Things, all this, it's a big problem when it comes to security. And in traditional network, if as suggested by vendors, if you put it in a one single layer 2 domain, it's a big problem because the segmentation is really hard to achieve. So then we start looking into more and more, and turns out, so after talking to a couple of dozen of vendors, all of them have multiple types of devices. We discovered that there's even more unknowns in the network when it comes to them. For example, it's some very unpredictable behavior, like devices don't, when connected to the network, they don't request DHCP for like 30 minutes, as So instead of, so we try and troubleshoot the network, and it turns out it's actually normal devices behavior, which is very annoying when you try to troubleshoot. So another one, yeah. So as I said, the broadcast. On top of it, when we get to like large network for let's say 1,000 devices, and now imagine all the 1,000 devices talk to each other via broadcast and consistently, and also they're not very powerful devices. So when they receive 1,000 broadcast packets, they're not exactly processing them very very fast. So they start dropping them, and in these buildings, it becomes nearly impossible to monitor because you get a consistent false positive alerts and any troubleshooting. It's for troubleshooting and monitoring. It's not exactly the best case scenario. Also, Trevor mentioned BACnet, which is a legacy. Well, it's still used, but it's pretty old protocol that is used. And in order for it to make it work with AP, it has to be mapped to so BACnet numbers have to be mapped to IP addresses. And what happens with some of the devices, if you just disconnect and reconnect them from the port, they lose the mapping, and it has to be manually remapped, which is and on top of it, in order to do that, you have to there has to people who specifically know how to work with this device. However, most likely, you guys probably, if you ever work with IoT systems, the first thing people say, it's like, oh, it's a network problem, probably a network failed. That's why devices don't work. We just unplugged and plugged the cable back in. So after some investigation turns out it's not just a network problem. It's actually devices. So now, why we want to use Faucet as an actual network for IoT and building management system? First of all, as I said, we have a security concerns because most of the devices are considered to be compromised even by the time they arrive. So we can't really trust those devices at all at where the current industry is. So we have to make sure. Even so, they in a lot of cases we have to put them in a flat layer 2 network. In traditional network, we wouldn't have a lot of options. However, Faucet gives us an option that SDN provides, which is ACLs, implementation of ACLs on a layer inside actual layer 2 domain. And for IoT and building management system, which it's incredibly helpful. Broadcast and multicasting points. As I said, when each device receives 1,000 broadcast messages, it's not necessarily the most effective use of the network, and it causes a lot of problems. So with Faucets, we can actually specify, instead of, even so it will be broadcast packet, but we can define where this broadcast sent to. So if out of 1,000 devices in a smart building, if one device sends a broadcast packet, you don't have to forward the entire building. So the same goes for security policies and responsive changes. And one of our plans would be as we're moving forward towards generating access lists, it would be to actually more to improve access lists based on the vendor specification or based on what traffic is learned. So besides the fact that we can get vendor specification, we also use Faucet to learn traffic, to learn existing traffic patterns. Since most of the, as I mentioned before, since most of the vendors actually outsourcing TCP/IP implementation of the devices, and they're not able to even answer sometimes questions to define which ports, which type of traffic we should look into. We can actually start looking into what traffic goes through the network, what patterns are important, what patterns are not. So even so, we may not be able to get information from them, but we can learn it. So how the Faucet network that we implemented looks like. So this is our current implementation, and we use, those colors really don't work very well here. So we use 2 controllers and tier 1, tier 2 switches and CPN. So tier 1 and tier 2. So tier 1, as you see, it's more like more like an aggregate layer that's in our implementation. And tier 2 is where we connect an actual host. So this is it's implemented as a single stack with tier 1 switches as the root of the stack, but it's active standby mode. So only one tier 1 switch is actually root of the stack at the same time, but we have a LACP up to our egress points. We have we have different implementation of the egress, but it doesn't matter. We have LACP that we're currently considering of like looking for if we need to use LACP everywhere or not. However, egress is currently our layer 3 gateway for the entire network, and Faucet network, which is everything like tier 1 and down. This is just layer 2 fabric that powered by Faucet. So we have as I said, tier 1 and tier 2 switches, as I said, is active standby from a switching perspective, and controllers are active standby from actual controller perspective. We use failover on the interfaces, and they have the same Faucet configuration on the both controllers, so they can just fail over in case of something happens to one of them. And CPN switches for the control plane network. So as I said, that's I already covered like the thing that we learn when it comes to devices behavior. And yeah, I think I already covered that in my previous slides. I rushed a little too fast. So testing and automation. Actually, one thing that I didn't cover, I'm sorry, I forgot. So the line that you can barely see from tier 1 switch to controller 1, it's actually a monitor port. So this is the port that we specifically added in addition to we can monitor of traffic that goes through the network. And this is the one that I mentioned before, that we can actually learn network and discover the traffic patterns, discover what like for troubleshooting, monitoring, and in general, like learn how the IoT devices behave. That's what it's for. So as I said, testing. So during our deployments, one of the key factors, as also Trevor mentioned and Doc as well, it's automation of all the tools that we can use, which includes actual network testing, and besides testing devices, how they behave, but also we can use all the tools available that Faucet gives us in this DN world when it comes to network behavior testing. So now the question is, will I will stop seeing? I don't expect so, because honestly, the industry is growing so fast that even so, we really want to, and we hope that we can make more standard approach. However, in near future, unfortunately, the building systems are so large and they so barely getting replaced to upgrade. I don't think we'll see like it's shifted in a couple of years to something standard. Especially considering how large how large some of deployments are. And as Trevor said before, like as soon as the building is built, the network and the devices, they're there, and like they're not gonna fly another like the huge with helicopter with all the with all the basement stuff to replace it. So far we have to figure out how to support it and how to maintain it, and the most important, how to secure it, because like it's one of the key concerns in this field. So that was it. Thank you. Do you have any questions?
So you showed one egress, layer 3 gateway, a couple of controllers, a couple of switches. That for one building, or can it be larger than one building?
So we technically there's nothing prevents it, because I'll just go back to the diagram. So nothing prevents from scaling. The thing is, there's a two. It's more of so far we would prefer to keep it in one building as far as architectural decision, because it's easier to deal with a building as an independent entity just from management perspective. Plus we don't have to worry about interconnect between building. Plus if building certain things are important to stay alive, even if there was like complete lost connectivity to internet, because there are some systems that's responsible for like basic operations of the building. So we prefer to keep them isolated, but technically nothing prevents if we have to. Also, with more and more going towards smart buildings, we expect to see larger and larger like implementations, especially with big buildings. And it's let's say it's 500 or 1,000, 2,000 devices. It's almost doesn't make sense to make like to add them together. It's easier to keep them separate.
What are your thoughts on host
No, I don't know.
Basically, that's one of the things that have been talked about for the IoT. You would have actually do secure public.
Yeah. So go ahead.
I wanted to get your thoughts on.
So I'm all for all security possible feature that we can enable in the IoT world, to be honest. But my concern is it seems to be very difficult to get everybody in the industry aligned on some specific implementation. That's why we went and how we can address it from backend perspective, just because talking to vendors and get them aligned to accept some specific standard, it's become very difficult, especially because there was like already billions of devices implemented. So
Even backnet over IP,
yeah, backnet over IP, but backnet is like protocol from 1986. You know, it's
yeah, I know. That's the most deployed one, though.
yeah, but that's the thing. Like it's from 1986, but it was implemented and it's still out there, like very heavily used. And unfortunately, it's not the most elegant implementation of network, to be honest.
So I'm going to try and be quick, but I have a little bit of a long question. So I have a lot of sympathy for people who have to operate devices. Backnet is a particular pain. It's easy to bash old protocols. My previous job, we had non-directed broadcast because engineers design things. They said, we need a message bus, so we're going to and so like I have a lot of sympathy for that, but I sometimes wonder, and this isn't actually, I sometimes wonder if we're not actually being unfair to it seems like we shift the goals. Like we say, oh no, we don't do things like directly broadcast. Or actually, you shouldn't be using broadcast, you should be doing multicast. Oh, actually, multicast is really hard, we're going to turn that off. Like, should we not be setting some sort of expectation to say, this is what networks, these are the kind of network designs that scale? So that's the statement part of the actual question is, Google makes Chromecast, and Chromecast is something that relies on their recovery and hacking enterprise networks in mind. So if you've been able to actually speak to people who build applications within your organization, try and figure out this tension.
Yeah. So addressing to the previous, the initial statement as far as being unfair to like broadcast, multicast, but like with anywhere anything else in the software development, it's iterations, right? We have to learn. So yeah, when the first protocol was built, it was built with the knowledge that was available at the time, and it served the purpose. And then over time we learned that maybe there are some problems with that specific implementation, and it's time for the new iteration. And there are specific thing that works and something that don't. That's like in the software development world, that's normal, right? This is just iterations. I'm not saying it shouldn't have built this way in the first place. It's just something that let us learn. So now we just need to see what's from now, how we can improve it, what's the next step, how we can make it better. Traditional network also was very useful for a long time, right? It's now we want to shift to SDN. So the second part is as far as Chromecast, yeah, Discover is it is a broadcast UDP, all those things, and as far as organizational, yeah, our organization is really big. It's hard to keep up, and it's however still not excuse. Yeah, we should probably maybe see how our own company is doing in the IoT field. Also, as far as Discover or communications, there's also a big difference between, not a big, but still, from the mentality of approaching and broadcast as discovery tool or as entire communication way. If you use broadcast messages to communicate consistently, that's a lot bigger problem than the discovery phase.
That's why you have unique.
Yeah, yeah.
So this is an interesting diagram. I know a whole bunch of things. Broadcast model. So that essentially have additional applications there on top of Faucet, and it is all these Faucet rules. Because I don't think Faucet natively does these things.
So when it comes to, you mean to like access list or?
Yes, to create the access list, to restrict the scope of a broadcast.
Yes, that's additional work. Like we're working on. So when it comes to access list right now, we're not at the stage where we can have granular access list yet. That's where we want to be. Currently, we have access list like relatively static because we're still in the learning phase. However, that's our plan is to have a tool that will allow us to do it more granular and more flexible.
So what do you mean by granular access list? So per device, you will have a rule or
So most likely per type, but also it depends on the implementation because devices are so different and there's also different regulations even depending on the country. There's different vendors depending on the country. There's different requirements. There's and based on that we have different communication patterns that we need to support. So yeah, but based on types, based on specific thing that we learn about device.
it's a type. How do you identify the type? Will it be a certain according to a type device, or because there's nothing inherently in the network packet which tells you what the device is.
Yeah,
So
that's.
you might have other mechanisms of classifying them.
Yeah, in network packet itself, we don't have. There's nothing that actually gonna tell you what type of device, unless it's MAC address very specific to a vendor. Even so, a vendor can have like multiple device types, but at least we can see what kind of traffic, what kind of ports are going through. This is still like very experimental stage, so like we're still working on it.
I'm almost interested in kind of whether an SDN solution better than like there has to be a compelling. So my question for you is like, what's the main advantage of this approach or Faucet versus a legacy approach of putting devices that need to talk to each other?
So, yes, that's a very good question, and that's the main reason why. So there is a lot of, as I said, if we knew the specifications from a very beginner, if a lot of devices could give us specific data, what communication is required, it would be easy at least to consider that option. I mean, we still have like most of the networks, pretty much all of the networks are still on the traditional networking. However, there are some devices that in order to implement fast, the vendors just the old direction that we would receive would be to put them all of the devices, regardless if they need to talk to each other or not, to the same layer 2 to one layer 2 domain. And one of the examples, as I said before, was some sort of like chain communication. And instead of defining which devices in chain should communicate, they would ask us to put the entire system on a flat network. And in the end, we end up being with like hundreds and hundreds of devices on the same network. Plus, in a traditional network, even if we do want to create some restrictions inside of this L2 domain, we can't. Like, I mean, we can, but it's extremely requires a lot of resources, and it's a very inflexible solution because it has to be like access lists. Plus, we get to learn. One of the key things that allowed us to learn the traffic that is going through the network. And analyze and take it from there. We can like improve and see how we can improve. I'm not even saying like this is still on a relatively like new stage. So that's what we're trying to do, and we'll see how it goes. Maybe yeah.
With all IoT devices, there's also a need Faucet going to be a Faucet enabled switch being the
So I just want to clarify. So the word gateway is a little bit overused because
that's the reason.
yeah, that's how I want to clarify which gateway you're referring to, because it can be gateway from a network perspective. It can be gateway from actual IoT gateway, whereas devices send data to. So which one you're referring to?
I think gateway is the one that takes the data out from the current network into a much bigger network. So, for
Okay.
example, if you are Google and you have one data else and you're getting this building out, probably the gateway would be whatever is there.
Yeah.
It should be as simple as that.
Yeah. So the current implementation that we're working on right now, Faucet only provides take care of a layer 2 fabric, and routing gateway, which is layer 3 gateway, is egress, which is actual data network in the building. This is not necessarily. I'm not saying that this is the only way to do it. There are multiple ways to do it. This is the one that we found the most useful for us at this point. And as far as communication to a data center and to IoT gateway, where actually data needs to be delivered, so that's already the egress routing that takes care of that. All right. Anyone else? And that's it. Yes.
Getting back to Trevor's talk, where he talked about bias and that type of test, could you also envision that to actually provision the production network?
Yeah, actually, so Trevor and I will work pretty close on the Faucet network, and Trevor, like the tool that he's working is definitely going to be extremely helpful on both, on maybe ACL not maybe, and on the ACL generation as well, on learning traffic pattern, of course, yeah. All right, thank you.